Okay, so the title is Hard Integrals, and they are hard. I believe they're hard anyway. They're hard because they're tricky, but they do involve something simple. They involve a U substitution. So the first thing I'd recommend to do is, if you see these integrations, it's really the radicand you're trying to figure out, because that's going to be your substitution of radicand. And looking at it, it's massage time. So let me write this down for you. And I'll look at the radicand, and this is a fourth root. And let's write this down. And I'm going to put it over here. It's x4. Oh, before I go forward, I want to point out the domain is all real numbers except 0 in this problem here. All right? So anyway, let's not worry about too much about that. It's an indefinite integral. And I'll write this one over here. I'll write x4. I'm writing the radicand down. Plus 1 to the third power. I'm going to write that a little differently. I'm going to write it as x4 plus 1, that whole thing to the third power. And then I'm going to factor it. And how do you factor that? I would factor x4 out. And you get x4, and then you get 1 plus x to the minus 4, and it's all cubed. Right, now someone says, why are you doing that? And the reason for that is that if I differentiate that, I would see something that would be in the denominator, because x to the minus 4 when differentiated would be minus 4x to the minus 5. So I would have 5 factors of x in the bottom. But unfortunately, I'm only seeing 2 now. So I don't think this is going to work totally. Now what I'm going to do now is take the cube root of that. All right? And let's put that down. So I'm going to write down the cube root. I'm sorry, fourth root, not cube root. And I put in everything, right? So fourth root, fourth root, fourth root. Again, I want to tell you what I'm concentrating on now. Just this. That's all we're concentrating on. And I'm looking at that, and I still have to simplify the radicand, because taking the fourth root of that, I could do it. But let's take a careful look at that. Well, I don't think I really need to, but I'm going to do it anyway. x12. Then you get 1 plus x to the minus 4 cubed. And let me do that now. What do you get there? You get x cubed, right? Fourth root. 1 plus x to the minus 4 cubed. All right, I'm going to look at that now, and I'm going to put in the problem. And I'm hoping to see something. If not, though, I erase it and try again. I get 1. We already got an x squared, so I get x5 now. And then what do you get? You get the fourth root. 1 plus x to the minus 4 cubed. Now I'm seeing the u substitution. And the u would be this over here. And the du would be minus 4 x to the minus 5 dx. So I'm going to say minus 1/4 of a du is going to be 1 over x to the 5th power dx. So I'm kind of ready to do the substitution, hoping that things do work out as advertised, that u substitution does work. I'm trying to go to u's. And the first thing I want to look at is the differential. So I'm looking for this, and I do see that. That's right over here. What's that going to be equal to? Minus 1/4 of a du. Okay, that's done. And then what do you get? I got 1, and then I got the fourth root. And let's look at that bottom. What's that going to be? Well, it's going to be u to the 3rd power then as a radicand. This looks much easier to handle. What I'm going to do now is rewrite it. So minus 1/4. I'm going to say u to the minus 3/4 du. I can integrate this, minus 1/4 u. I'm going to increase the exponent by 1, so it's going to be 1/4. And divide by 1/4 or multiply by 4, plus some constant of integration. Let's keep going. What does this give me? Minus the fourth root of u. What's u? It's 1 plus x to the minus 4, and then plus c. I would say this is a good answer. Put a box on it. I'm done. You could check it if you want. I do want to go to the key, though, and there's some subtlety in the key. Right? So in the key, I'm looking for that answer. Do I see it? I see it right over here. But then they go on further and they have something else written down. I just want to briefly go through that with you. Right, you don't have to do that though. So it's going to be equal. This is minus the fourth root. This is plus c. This would be 1 plus 1 over x to the fourth. Typically, we don't like negative powers. So what do you get? Fourth root. You get x4 over here. And then you get x4 plus 1 plus c. Now the fourth root of x4, and I was a little bit lax over here of saying something about the cube root. But you know what? I'm not too worried about that. Towards the end, I'm going to take care of that. And what do you get over here? The fourth root of x4 is actually the absolute value of x. What do you get on top? The fourth root of x4 plus 1 plus c. Now, let me look at the answer key and emphasize that that answer is also being listed. All right, it's right over here. What answer is preferred? I don't know. I like this one better than the other one, but the bottom line is most textbooks would probably write the last one down. Thank you. Let's go to the next question. And it's another tricky one. And again, looking at that radicand, again, you could do manipulation of the radicand, but I'm thinking that, that if I differentiate the radicand, I would certainly want to see that in the problem, and certainly differentiate and that's happened. It certainly would be nice if I get it to a higher power. So what I want to do is I want to see if I can get that to be a higher power. And the way I'm going to do that is, let's take a look. So I'm going to take this whole thing, which is x6 plus x cubed, and that's going to be the cube root of x cubed plus 2, all right? I'm just doing the integrand at this point, right? That's all I'm doing. And what I'm going to do is I'm going to take an x from it. Whoops, I didn't mean to do that. And what would you get? You'd get x5 plus x2, and then I get the cube root of x cubed plus 2. Again, I'm trying to take this x and bring it on the inside. And one way to do that is maybe just rewrite it as a cube root problem. What would that be? It would be the cube root and of x cubed, right? And then you get x5 plus x squared cube root of x cubed plus 2. Again, it may be wishful thinking. I may get this on the inside of the radicand, and even when I differentiate, I still don't see it. That's possible, all right? Let's keep moving. What do you get over here? x5 plus x squared cube root. Let's see what you get. X6 then, right? Plus 2x cubed. All right, so I'm going to write that down, and with the hope that that's going to work out. So what do you get? You get x5 plus x squared cube root of x6 plus 2x cubed dx. I'm going to say u equals, because this will differentiate to something in the problem, x6 plus 2x cubed. What's du going to be equal to? 6x5 plus 6x squared dx. I'm going to divide both sides by 6. 1/6 of a du would be x5 plus x squared dx. And I do see that in the problem now. So I want to rewrite that over. I'm going to do it over here. And what do you see? Let's be really careful about this. I'm going to do the differential first. And the differential, this time the differential, I do see that, is going to be 1/6 of a du. So I'm going to put the 1/6 on the outside and put a du over here. All right, then what do I got? I got this u to the 1/3 power. All right, the u substitution did work out nicely. What do you get? 1/6 u. You're going to increase that by 1, so it's 4/3. And then you're going to divide by 4/3 or multiply it by its reciprocal 3/4, plus some constant of integration. Well, let's write that down. And I'm looking at it. I'm going to say it's now 1/8. I'm reducing the fraction at this point. And then it's really, 4/3 is really, it's really a u, and then a cube root of a u. and then plus some constant of integration. I got to go back to the u's. I got to go back to the x's. And it's going to be, what's u? Well, it's x6 plus 2x cubed. And then it's going to be the cube root, we'll look at the key in a moment, of x6 plus 2x cubed. You know, I could probably do something else with this. And I'm noticing, I don't mind the answer, but I'm noticing I can factor these things. And that's always something that we look forward to, especially if we have to analyze this guy over here. Let me put that down for you. So the first factor, which is this x6 plus 2x cubed, I'm going to say x cubed comes out. And we left over there x cubed plus 2. And even from the root, I'd factor out x cubed would just be x, and then you get the cube root. And again, I factor out an x cubed, so I'd get x cubed plus 2. And this is all over 8. Let me neaten that up a little bit. And now what do you get there? You get x4, x cubed plus 2, cube root of x cubed plus 2 all over 8 plus some constant of integration. I guess that's probably the best answer. I'm going to look, when I say best answer, my best answer, x4, I do see that. I see the x cubed plus 2. I see the cube root of x cubed plus 2. I do see the 8. I do see the plus c. I also want to point out, this answer is also being listed in an equivalent form, by the way. I do see the 8, do see the plus c. And this over here is really x6 plus 2x cubed to the 4/3 power. And that's fine to put that down too, by the way. Both answers to me are fine. Right, so again, this is an example of tricky questions, all right? What are the tricky questions? They have to do with U substitution or what you learned in Math 121, which is Calculus 1. Thank you.